Again, Matthew Young from the National Cancer Institute, and so my area of focus is on biomarkers. This is a interesting session for us. Our next speaker is Constanza Camargo. She's a fellow NCI scientist, and she's working in the Division of Cancer Epidemiology and Genetics. She's going to talk about biomarker discovery in gastric precancer lesions. So, and I owe my presence here to Constantina. We met at a meeting, at Early Detection Research Network meeting 4 or 5 years back, and she has brought me into this important topic about looking for biomarkers for gastric cancer. So thank you very much.
Hello, everyone. I hope you are ready for the change of topic and the change of accent. Juhan and Robert, thank you for the kind invitation. I am really happy to be back in this beautiful campus and delighted for the opportunity to be able to see you all and to discuss the ongoing and future collaborations. Matthew presented this picture yesterday. This is the framework of the EDRN network, the Early Detection Research Network that was established by NCI more than 20 years ago. These are the phases of biomarker discovery, and I'm going to explain them in a little more detail. So the phase 1 is the preclinical exploratory studies, and the typical example is just differences in tumors. So we are looking for signals comparing malignant versus non-malignant tissue. Then we have the phase 2, the clinical assay and validation, and these are mainly case control comparisons. So these are prevalent cases of gastric cancer with individuals without cancer, right? And the idea is to have discovery and validations within these phase 2 studies. The phase 3 studies, retrospective longitudinal, these are the studies that use pre-diagnostic samples. So these are samples coming from population-based cohorts, individuals that have been followed for years, they were healthy, followed over time, we collected biospecimens over time, and then we wait until they develop cancer. So they are retrospective in the sense that they are already in the freezer when we have a marker, right? But they are prospective in a sense that we start with healthy individuals, and we follow them over time, and ideally you expect samples that were collected at least 10 years earlier, just to be looking for the right biomarkers. The phase 2, that is called the prospective screening, is when we have already a marker that we believe is good, so we apply this candidate screening marker to the population and do final diagnosis and see how many cases were developed, and that's the prospective phase of the specific screening marker. And the phase 5 is the cancer control, and that is just when we are certain that we have already passed the phase 4, and we are concerned, we want to address if indeed there is a reduction in the burden, particularly mortality, for by this particular marker. And we account for acceptability of the marker, the economic cost, and things like that in this first phase. I don't want to discourage you, but the biomarker development is a very difficult task. Indeed, in the EDRN, I checked the website, and 90% of the studies that they have are phase 1 and 2. 10% are phase 3, and less than about 0.2% are phase 4 and 5. And they have a very committed and skilled group of investigators from all over the country working on this, and some of them here. So please don't get discouraged. The task is difficult. If it was easy, others will have done it already, right? And we like challenges. So let's continue looking for the right mix of biomarkers. As you all know, gastric cancer is a heterogeneous disease, and according to the molecular classifications, we have 4 major groups. So it's likely that the screening tool for gastric cancer will be a multi-biomarker panel, not because we want to differentiate the specific subtypes of gastric cancer, which hopefully, which it will be ideal, but because we are looking for complementary markers that push sensitivity, maximize sensitivity, and maximize specificity, right? That's why we need it. Some key concepts, we all know successful prevention and control of gastric cancer depends on early detection. This is a treatable disease if we identify the lesions early on. The key high-risk groups are high-risk populations, family history, individuals with family history of gastric cancer and advanced intestinal metaplasia with the definition that Blanca and others have already provided to you. The current screening technologies, including endoscopy, radiography, and pepsinogens, are the ones that are being used in China, and I congratulate our colleagues in Korea and Japan, particularly for the great effort that they are doing and the many lives that they are saving every day. Screening reduces cancer deaths, but unfortunately, open endoscopy is invasive, expensive, and completely impractical in areas such as Latin America, as Arnoldo described it to us in the earlier session. So there is a need for non-invasive biomarkers that accurately identify individuals that are at high risk of having gastric cancer that need further testing. Just to remind you about the lifetime risk of developing gastric cancer in the US is 1 in 95 men, in women 1 in 154, and globally 1 in 54 men and 1 in 126 women. And as Monica presented to us, the risk is of course very high in individuals with CDH1 pathogenic variants. For biomarkers, there are two main questions. Can non-endoscopy biomarkers be used accurately to detect gastric cancer? And the second one, if we think about the preneoplastic lesions, is can biomarkers be used to accurately determine which individuals are at high risk and need further diagnostic testing, and that is upper endoscopy. It will be ideal to have a non-invasive biomarker that allow us to identify individuals with potentially intestinal metaplasia that we can then channel to endoscopy. That will be the more rational use of endoscopy because in general, in many of the gastroenterology departments, we are full of with individuals with healthy stomachs, right? So let's continue working on this difficult task. So far, the approaches that have been used to investigate biomarkers are candidate markers or agnostic studies. And there are a range of domains that have been studied: proteomics and microbiomics, genetics, epigenetics, metabolomics, and autoantibodies. These are the major ones. My list is not exhaustive, and I haven't reviewed all the literature, but I got a good sense about what is there, and I'm going to present some key studies. Starting with Pepsinogen, has been around for, at least 20 years already. This is the summary of Pepsinogen and atrophic gastritis of the corpus. A more recent meta-analysis published this year, combining 49 studies, comprising about 22,000 patients. As you can see, significant heterogeneity, and this is atrophy with and without intestinal metaplasia, as Blanca alluded to us. Atrophy is difficult to diagnose. We have reliable measures with metaplasia because it's a more characteristic lesion, but for atrophy in general, the pathologies don't agree so well. So that we are seeing in these particular studies. Pool sensitivity, 70%, pool specificity, 93%, area under the curve, 0.90. For Pepsinogen and particularly gastric cancer, sensitivity 69%, specificity 73%. So in conclusion, Pepsinogen is not bad, but it is not good. So we need to build on Pepsinogen, right? It's something that works, and we see that it works better in some populations than others. So in my opinion, for any biomarker development, we need to start with Pepsinogen and build on Pepsinogen. As we all know, based on the natural history of gastric cancer, inflammation is an important component. So inflammation-related biomarkers and immune-related biomarkers are good candidates for circulation. So here I am summarizing the phase 3 studies. And some of the phase 2. But the ones highlighted at the phase 3, so these are pre-diagnostic samples taken years prior to the development of cancer. The first study is by our colleagues in Japan, Dr. Sugani's group. So they started with 2 markers, and they identified 2 significant associations. Then we have a study in the Shanghai women conducted by Charles Rapkin, my colleague at NCI. 4 markers, Luminex technology, significant association with interleukin-6. Then we have a study by Myra Eplane, 8 markers, Luminex technology, that is the Shanghai in men, just interleukin-8, no validation for those studies, significant associations. Then we have expanded, and we have tried to fit all corners. So we did intestinal metaplasia and dysplasia using samples from the Mexican H. pylori eradication trial conducted by Julie Parsonet in Chiapas, in a high-risk area of Mexico. We expanded the number of markers. We tested 28, and we have some significant associations, but the correction by FDR is just put them a little in a less exciting point. We have done early stage non-cardiac gastric cancer, a collaboration with Dr. Matsuo in Japan. For this particular study, our controls were all infected by H. pylori. We wanted to restrict because we need to account for H. pylori, the role of H. pylori. So we expanded in terms of the platform. We use Olink, which is an emerging and getting very strong platform that is doing at this moment thousands of biomarkers. For that particular study, we used the immuno-oncology panel, 85 markers. We have 2 significant associations, but unfortunately, they are not significant after FDR correction. And then using samples from Dr. Sugani's studies in Japan, very precious samples collected more than a decade prior to the development of gastric cancer. Combined, we have about 140 markers, and as you can see, very limited number of markers, and more importantly, the magnitude is relatively low, and the corrections after multiple comparisons, they don't stay. So I think that inflammation-related biomarkers and immune-related biomarkers are not really the way for screening. Moving now to Hpyloliserology. This is the more recent meta-analysis combining all serology studies addressing the association with H. pylori. These are only phase 3 studies using whole cell ELISA. As you can see, the overall pool estimate is 3, and when we stratify based on the time between collection of the sample and cancer diagnosis, we can have 2 groups. The groups that is 10 years or earlier, the risk estimate about 4, and for the complementary group, the risk is about 2.5. Moving to the recent studies using immunoblot and multiplex that are not just testing whole cell, but they are testing particular markers, we have a relative risk of 9 when we restrict based on the lag period between collection of the sample and cancer diagnosis. We see that for samples collected at least 10 years or more, the risk estimate is about 15. And we have one study that is the complementary with the risk, relative risk of about 3. As you can see, these associations are stronger because all of these multiplex assays include KG serology. We know that the KG antibodies last longer, and we have a hypothesis, and this is based on the beautiful work by Manuel, showing that in the animal models, the KG positive strains go deep into the glands. So even when someone receives eradication, we believe that some of these subsets of positive KG strains stay there, and they continue eliciting antibodies, and that's why this signal is maintained. Additional results based on these multiplex studies. One study highlighted that is using pre-diagnostic samples, also from the group by Mayra. So she used a 13 marker panel multiplex that was developed by the group of the German Cancer Center. They identified significant positive associations with OMP and HP 0305. The same panel was applied to a study of preleoplastic lesions combining intestinal metaplasia, indefinite for dysplasia, and dysplasia, and they confirmed these two associations, OMP and HP 0305. We have been working on this field also, and in collaboration with investigators from the University. Arizona State University, we have expanded. They have a platform that allows you to measure simultaneously as many markers as you want. So they developed an array specifically for H. pylori, and for the first study, we did a case control comparison, a phase 2 study, targeting more than 1,500 epitopes of the H. pylori proteome. The proteome of H. pylori is dynamic in the sense that the plasticity of the genome also leads to a plasticity in the proteome. But we believe that we have about 90% of the proteome of H. pylori represented. We identify some inverse associations because, remember, it was a case control study of cancer, so we have inverse associations because of the atrophy and other potential factors. We couldn't include KG in the first array, so we did KG with general ELISA, and we have a positive association with KG, and that was the only positive association. We did some discriminatory models, and the ROC for the combination of KG and 3 that are not redundant antibodies leads to an area under the curve of 0.73. We recently published our study on intestinal metaplasia, and this is based on our GCPL study, the Gastric Cancer Precursor Lesion study that I'm conducting with Alejandro and Arnoldo in Chile. We use samples from the first phase of the study. We observe that individuals with intestinal metaplasia, they have a stronger humoral response as compared to individuals with non-atrophic gastritis. We identified about 11 significant associations. 5 of them are positive, and the strongest association is OMP27. That particular protein is one of the hits of the GWAS of gastric cancer of H. pylori genomes. As you may recall, there are 2 GWAS of H. pylori genomes, one in European strains, one in East Asia strains, and the OMP is one of the hits of the OMP. We saw, as expected, an association with KG, and related to the inverse associations, we see some overlapping with our previous study of cancer, particularly for NAP-A. Combining Pepsinogen and serology, this is one of the strongest evidence that we have, and a study from Japan, almost 4,500 individuals followed for 16 years. And as you can see, the distribution by A, B, C, D groups, as you may recall, C and D are the groups at higher risk, and as you can see, the hazard ratios for Group C for overall gastric cancer, almost 18, Group D, almost 70, and importantly, just to emphasize, when you stratify by Lauren, you see the association equally strong for diffuse type, showing that some of the diffuse cancers are associated with H. pylori, and they are associated with atrophy. Related to Epstein-Barr positive gastric cancer, we were very pleased to publish this paper. This is the complete immunoproteome of Epstein-Barr, comparing individuals with EBV positive tumors and individuals with EBV negative tumors. We have a highly discriminatory signature. This is a phase 2 study. We are trying to get additional samples for pre-diagnostic samples for a phase 3, but we believe based on the strong signals, you can see the axis of the pictures to your right, that those ratios, some of them are above 10, almost, about even one of them is almost 100. So we are confident with this signature. The EBV-associated gastric cancer specific humoral response was exclusively directed against lytic cycle, intermediate, early, and early antigens. And this is one of those potential markers that if we would like to identify in the future the specific molecular subtypes, I think that if this is confirmed in the additional phases, we will have something interesting with this particular molecular type that somehow the advance in the knowledge of this particular subtype has been stopped because you need a piece of tissue to do in situ hybridization and to be able to classify if someone has a positive or a negative tumor. Moving to genetic susceptibility, this is information from the Kaduri Biobank. They did a very beautiful study, a GWAS, and then confirmation in phase 3 for a polygenic risk score, including 112 genetic variants. And as you can see, they developed the score. They are doing quintiles here. This is a linear association. For the quintile, number 5 versus number 1, we see an association of about 2. Is relatively strong, in the sense that we are not seeing these ratios every day. But of course, this is something that could be added potentially to the panel. Generalizability to other racial ethnic groups is under investigation. Indeed, we are conducting 2 GWAS studies, one in Western populations and one in Hispanic populations, and we are going to test this particular polygenic risk score to see if the signature maintains the association. Moving to circulating microRNAs, I think that this is one of the biomarkers that is still in the front. And 2 studies here. The first one is the one that was mentioned yesterday. After they have tested 578 microRNAs, they identified 12 as highly discriminatory with an area under the curve of above 0.90, and the combination, the last model that I am mentioning there, the 12 microRNAs, a model adjusted for age, Hpyloliserology, and the ratio of Pepsinogen 1, Pepsinogen 2, moves the area under the curve from 85 to 89. And the study by Dr. Abe here with us, a very important study, early stage gastric cancer. He tested stages 1A and 1B, 90% of them, and with some stage 2. And he has a very nice discovery and validation set. He tested about 2,500 microRNAs, and he has a signature of 6 that is highly discriminatory. So I think that this is something that we see additional studies, phase 2, that are also suggesting that microRNAs could be important. So I think that, the mix of Pepsinogen and serology, as you did, as the collaborators from Singapore have done, is a good way to go. Of interest, you may recall from TCGA the hypermethylation of gastric tumors, right? As you can see, the colors are representing the 4 subtypes. We have the king of methylation, the EBV-positive gastric cancer, and the next is the MSI. So methylation is an appealing concept, right? And we know that methylation is used in Cologuard, but it's not used in circulation. It's used in stool, right? So we have all the cells that are moving through the intestine, and then it's relatively easy. But in circulation, things get a little more complicated. Information from the GRAIL study, just complementing what Dr. In presented to us yesterday. For gastric cancer, we have information from the abstract that was presented in ACR in 2021, and the sensitivity for gastric cancer is about 65. But the problem is that there is a combination of multiple stages, as you can see. They only have 30% of tumors as a stage 1 and 25% as a stage 2. But for gastric cancer, we assume that in this particular set, the most are stage 3 or even stage 4. So unfortunately, suboptimal sensitivity for methylation. Yeah, the concept is appealing, but still, I am personally not convinced with methylation in circulation. Moving to metabolites, just to present the sex hormones, we have been very interested in the subject because this is something that has been on the table for years. Why men have higher risk of gastric cancer as compared with females, and we have strong observational data suggesting that estrogens may protect women against gastric cancer. So here I summarize the study. The study is available. So the first one was one conducted by Dr. Gordon in 1993, a very small study, but it was a phase 3 study. Sometimes you can start a little, no, you don't need to go step one, phase 1, phase 2, phase 3. You can jump to phase 3 if you have the samples, right? So he jumped to phase 3, and he has 13 incident cases, and he compared that with 52 controls, and he found a significant association with DHEA. We tried to replicate that DHEA association, so we started with a phase 2 study. This is a case control comparison with samples from my good friend and collaborator in Mexico, Gelda Leal, in a high-risk area in Mexico, Yucatan Peninsula. So this is non-cardia, so we tested DHEA, and we tested estradiol and testosterone. We identify an inverse association, as Dr. Gordon suggested, but we found null associations with estradiol and testosterone. We conducted with Charles a study combining incident gastric cancer, phase 3, with early stage gastric cancer, combining cohorts from the Korean multi-center cancer, the gold standard cohort from Iran, and the Esther cohort from Germany, with 2 samples from 2 case control studies of early stage gastric cancer. It was difficult really to convince people to get samples for this particular study, and that is what we do in the intramural program. Sometimes we take risks, and yes, it was null, but it was published, and sometimes these null results are very important and provide knowledge and redirect you to a different research. We wanted to do this in serum and plasma, but the PIs of this long-term population-based cohort, they say, no, the data are still weak. We can give you urine, so we took urine. Yeah, it's not perfect, the correlation between urine and plasma, but it was good for us to assess and to do this analytical study. So we used a panel that is at NCI that include the parent estrogens plus 13 metabolites, and we found absolutely nothing. Null associations. And then our colleagues at NCI, they conducted a study using samples from the NCI cohort consortium. This is incident esophageal adenocarcinoma with gastric cardia. The numbers are there, and they found a significant inverse association with DHEA for the group combined and remain for the cardia tumors. They found marginal inverse association with estradiol and null associations with the other markers that are mentioned there. The UK Biobank, one of our collaborators also from NCI and collaborators from the UK conducted this study. It was null for testosterone and estradiol, but they found an association with sex hormone binding globulin that was also seen by the study by our colleague Christian Abnett. So the association is not so strong, but it seems that potentially it could be something. So we need to start confirming, but I think that for the association with DHEA that I mentioned at the beginning, I think that we need to do a little more work, and hopefully we can do a prospective study for non-cardiac gastric cancer. Okay, so this is a little background for the antibodies. So in the previous meeting, I presented information about our analysis on trends. We once in a while update the gastric cancer trends in the US and in Latin America in particular. So this is our analysis for NACER 1995 to 2013. We confirm an increase in gastric cancer in young individuals, particularly women up to the age of 50. Stratification at 50 years of age showed that this increase is in non-cardiac tumors, particularly localized to the tumors in fundus and corpus of the stomach, and particularly women. we did some projections, and if we don't do anything about it, by 2032, important observations, gastric cancer is not going to decline any longer, and the risk of gastric cancer will be higher in females as compared to males. So we haven't solved the H. pylori-driven carcinogenesis, and we have an additional type of cancer emerging. We did a stratification by race ethnicity, and we observed a significant annual percentage change for Hispanic female, and for non-Hispanic blacks, and for non-Hispanic others that are mainly representing Asian Americans. We didn't see that trend, but I think that we need to keep an eye on that, because there are, as Dr. Yan suggested, in Korea and in Japan, they are starting to see an increase in gastric cancer in young individuals, and I think that it is going to start happening in more places. So we need to keep an eye on the trends. So following the observation in Hispanic Latinos, in collaboration with a physician in Peru, Dr. Torres Roman, we conducted the analysis based on mortality, because unfortunately in Latin America the number of population-based registries is limited. Just 20% of the populations are covered by cancer registries, and just 7% are high quality. So yes, mortality is not the best data, but considering that in Latin America, gastric cancer is diagnosed at late stages, mortality and incidence mirror each other. So, to be able to be inclusive, and because we were very interested in young individuals, we wanted to maximize power, so we took mortality. So for this particular analysis, we analyzed Hispanics in the US, people from Puerto Rico, and 16 Latin American countries, and as you can see, variable risk across populations, something that Douglas mentioned to us yesterday, the importance of disaggregating the groups equal that we are doing in Asians, we need to do it in Hispanics. Not all Hispanics are the same, and the risk of gastric cancer is also variable. Just want to emphasize observations in 3 countries. In Brazil, for example, in the last 20 years, the mortality hasn't moved at all. It's sad to see that the same number of women are continuing dying, even though the incidence is declining. And in Panama, as you can see, a slightly increase, and in the US also a slightly increase that aligns well with the incidence data that I presented to you. Following up on our hypothesis explaining this increase in young individuals, we believe that autoimmune gastritis is the driver. We believe that in the absence of this ancient member of the gastric microbiota from the equation, other pathogens may take the place, right? We know that autoimmunity, that bacteria can do mimicry and lead to autoimmunity. We know based on data from other autoimmune conditions that they are increasing. Unfortunately, we cannot really do it here in the sense that we don't have the number of biopsies had been changing over time. So hopefully we can do it based on markers in circulation and potentially enhanced to have population-based estimates. So for this particular study, we collaborated with investigators from the Finnish maternity cohort, and we have like a negative control with the ATBC study by NCI. The Finnish maternity cohort includes young women from younger generations versus the ATBC study, older individuals, all generations. And limitation, all of them are smokers. We tested antiparietal cells, and we tested anti-increase factor. We found a significant association with antiparietal cells. We found an interaction with H. pylori, the association being stronger for H. pylori negative individuals. Interesting, we didn't have the complete data for subsite, but as you can see, a strong association for tumors localized to the fundus and corpus of the stomach. The magnitude is 3 versus 25. Recommendations: collect and maintain informative specimens, and hopefully a recommendation that is given by EDRN reference sets for biomarkers from populations of interest, patients with early stage gastric cancer, patients with precursor lesions, patients with hereditary and familial gastric cancer, and individuals without gastric cancer that we follow, right? Just to be able to do the phase 3 studies. Some of the recommended biospecimens to try to develop and validate biomarkers based on recent results of well-designed agnostic association studies and conduct additional tissue-based studies to uncover the genomic landscape that leads to progression of cancer. And yeah. Coming back to the phases of biomarker development, key concepts: blinding and assignment based on in a random manner for testing are key for replication of phase 1 studies. The importance on reference sets, the importance on standard study designs, hopefully same protocol, multi-center studies, and EDRN has also provided the PROV, the checklist for studies phase 2 and 3 that I recommend you to check. Take-home messages: unfortunately, most biomarkers only exhibit a low to moderate diagnostic value for identifying malignant and premalignant lesions. We need organized and sustained efforts to move the field forward, and hopefully one of them will be the addition of gastric cancer to the EDRN network. And the hope is emerging technologies, that potentially will lead to better, more sensible tests, more agnostic multiplex. So there is hope there. Acknowledging my multiple collaborators, I'm very fortunate to have collaborators across the globe, but here I want to acknowledge Charles Rapkin, one of my key collaborators at NCI. I'm delighted to see this network growing and the multidisciplinary investigators working together. I think that working together and walking together, we are going to get far. Thank you so much. Just acknowledging the NCI.